The merge statement lets you insert, update, and delete table data with just a single statement. And it bases the changes it makes on the similarities and differences in the data. It joins a data source table with a target table, or a view, in order to perform the various actions. The operation it performs depends on the results of the join between the source and target tables. If data exists in both the source and the target, update the changed data in the target. If data in the source doesn't exist in the target, insert the data into the target. And if data exists in the target but not in the source, then delete it from the target. You have full control over how you define whether and how each of these actions occur for a particular row in the source table. The merge statement is transactional, so you don't need to explicitly define a transaction. If any of the operations fail, then the entire statement rolls back. The merge statement uses 5 clauses. The merge clause specifies the target data, such as a table, view, or other query. The using clause defines the source data. The on clause specifies how to join the tables, and this works much like a regular join clause. Then one or more when clauses define the actions to take based on the join matching. And then finally, the output clause returns a row for each action taken. The when clause is where all the actions occur, and you're likely to have more than one in a typical merge statement. The when clause has 3 different forms. The first is when matched, and with an optional and condition. Here's where you either update or delete an existing row in the target data. You can have at most 2 of these when clauses, and if you have 2, one has to have a condition associated with it. You can define either an update or delete statement in this clause. If you're using an update statement and more than one row in the target matches the statement, then you get an error, and you can't update any row in the target more than once. Similarly, you can't update and delete the same row. So there are some restrictions on how you use these. The second form is when not matched, optionally by target, and again an optional condition. This is where you can use an insert statement when a row in the source doesn't match any row in the target. You can have only one of this when form in any merge statement. And the by target clause is optional because it's the default. And then the third form is when not matched by source, and again an optional condition. This form of when clause kicks in when rows in the target don't match a row in the source. In this case, you can either update or delete the row in the target. You can have at most 2 of these in a merge statement, and again the second must have a condition associated with it. Now the optional condition on the versions of the when clause can be just about anything you can include in a where clause. You have to include at least one when clause in the merge statement, although the order in which you include them doesn't matter at all. Any triggers that exist on the affected target table will fire normally, but there's no guarantee of the order in which multiple triggers might fire if multiple operations are performed on the target table. So be careful of side effects when you're dealing with triggers. All normal permissions apply, so the user or the security context has to be able to perform the various actions. All right, so let's take a look at how a merge statement works. In order to demonstrate the merge statement, I'm going to use a dogs table that I'm going to create within the tempdb database. So here's the code. So it's going to create the dogs table, and it consists of a dog ID, name, birth date, death date, weight, harness size, and it has a constraint that this is the primary key. Okay, so a fairly typical table includes general information about dogs that you might want to record. So I'll go ahead and execute this code in order to create that within the tempdb database. Okay, so we've got the table. And now I'm going to insert some rows into the table. So this is going to form the target data. This is the data that I'm going to want to update using the merge statement. All right, I'll go ahead and execute that. And there you can see now the contents of that dogs table. So the scenario here is that this is an existing database that we want to update. All right, now we need to define something for the target table. This code is going to use a persistent table type. And then the code that actually uses this type will have a variable that contains a reference to the type. Okay, so this creates the type. So it's called type dog updates as table. And it has a structure that's essentially the same as the dogs table. Just makes it easier in order to update the data column by column. That's not necessary because, again, you have control about how the update operations are going to occur for each row. So you can have completely different schemas if that makes sense for using the merge statement in your situation. Okay, so this code just checks to see if that type already exists. I'll execute that code, and now we have that persistent type within the database. Okay, at this point, all the persistent database objects are now defined. So I can put them to use in a merge statement. So here's the code that actually performs the merge. All of this code here is a single batch because I'm defining a variable and use that in various places. Okay, so first of all, the code defines this variable that uses that table type. And then I insert some data into that table type. This is essentially an in-memory table. So this is the source data. So this represents the data that with the changes that we want to apply to the target table, the persistent target table. Okay, so the table is going to have 3 rows for Marty, Izzy, and Raja. And if I scroll back up here, you can see that Marty already exists in the table, so that's likely to be an update. Izzy already exists in this table, so that's likely to be an update. And then Raja here doesn't exist here, so that's likely to be an insert. So that shows how you can use the source data in order to update persistent table data. Okay, so then as the batch continues, I do a select star to display essentially the starting state of that dogs table. And then here's the merge statement. Now in this case, we want to do 2 things. If a row in the source data matches a row in the target data, execute an update statement to update the value of the fields. And then the second action is that if a row in the source data doesn't match a row in the target, insert the row. For other scenarios, you can define more actions as necessary, but these will do for this example. Okay, so here's the merge statement. The first is the merge clause. Recall that the merge clause defines the target. So this specifies that persistent dogs table as the target. That's the data that we want to update. And then the using clause defines the dog updates, that variable in memory here, as the source data. And it uses a select statement in order to read that data. All right, it also gives both of these aliases. There's nothing magical about the target. This is not the target because I'm calling it target. This is the target because it's in the merge clause. Same thing here. This is a name. It could be S. It could be any other valid SQL identifier. But this is the source data because it's in the using clause. And then the on clause here is the join condition between the source and target data. SQL Server has to be able to relate the rows of the source to the target, just like in a regular join. Okay, so that sets up the target and source data. And now I have a couple of when clauses here. These define the actions that we want to take when data matches or doesn't match between the source and the target. Okay, so in this case, when the data is matched, in other words, when there's a row in the source that matches a row in the target, we want to update the data using this code here. So this is pretty much a regular update statement. So update set the target name equals the source name. So we're just reading the values from the source into the target all the way through. And then the when not matched clause here defines a situation when there's data in the source, but it's not matched by this join condition in the target. In that case, we want to insert it in the target, and so this is a fairly standard T-SQL insert statement. And then the final clause here is the output clause. This returns a result set with fields for the action taken. That's that item right there. Oops, I don't want to move that. That right there. So this uses the action operator. And then it's also going to include all of the fields for the inserted virtual table and the deleted virtual table. So these work a little bit like a trigger. All right, then the batch finishes up by doing another select star from dogs so that we can see the end result of running this code. All right, so it's time to execute the batch. So I'll select the entire batch and I'll execute it. Arrange this a little bit so you can see everything. Okay. So here is the result set of the contents of the dogs table before we make any changes. And then this is the end result of the merge statement. And then the second result is the result set from the output clause. So it provides information about the actions that were taken as well as the data that was changed. All right, so if you compare the before and after dogs table, you should note a couple things. First of all, neither Jewel nor Topaz are in the source data table, so their records are unchanged. It's Jewel, null, null, 42, red, green, Jewel, null, null, 42, red, green, Topaz, 1996, 2006, 53, blue, yellow, and the same data here. Now, Marty's an interesting case. It may look like the data is unchanged. So we have Marty, 1997, 62 yellow. Marty, 1997, 62 yellow. But in fact, this is marked as an update. So this means that there was a match and the data was updated. But nothing actually changed because the source data for Marty was the same as the target data. So it did the update, and it counts as it as an update, but the data wasn't actually changed. Okay, then here's Izzy. She started out at 44 pounds. She's lost a few pounds, and which means that she's also using a smaller harness as well. So her data has been updated, and there's that record right there. So you can see the after is 39, and the before was 44, red, green, and red. And then finally, Raja doesn't exist in the table originally, so that's just a straight insert. Okay, so that's a fairly simple example of a merge. I have another example here, and this is something that I loosely derived from something I found in books online. So this example is going to use the AdventureWorks 2012 database. And what it's going to do is update inventory. And it's a fair bit more complex than the dogs example. All right, so let's go ahead and switch to the AdventureWorks 2012 database. And then I'm going to create an inventory orders table. Okay, then the next thing I'm going to do is create a stored procedure in order to update inventory, and this is going to contain this merge statement. So I first check to see if this stored procedure exists, and if it does, then I drop it, and then create it. So this is going to accept a parameter of order date, which is of type datetime. Now, one thing about this particular example, as described in this comment here, The order dates in the sales order header table are all date time fields with the default midnight time. If this weren't the case, then we'd have to include code in order to compare the date time values, allowing for a time element to be part of that value. But we don't have to worry about times because none of the data within the AdventureWorks inventory table has any time associated with that date time value. Okay, so just a note about the code. All right, so here's the merge statement. So we're going to use the inventory orders as the target. So that's this table that I created right here. So essentially we're going to be dumping some information into inventory orders and then updating it. And then it's going to use this select statement that uses a join between the sales order detail and the sales order header in order to generate some data in order to insert that into the inventory orders, or actually to use with the merge statement. So this is the source, and it's going to return the product ID, order quantity, and order date. And then there's the matching condition, just on the product ID. All right, so we have our source and target data defined. So now we can start defining the when clauses. So the first one is when the data is matched. In other words, the product ID matches a product ID between the source and the target. And the order date is anything other than the source order date. Then I'm going to delete the rows in that table that I created. Again, this is a merge statement where the target is that inventory orders table that I just created. Okay, so again, this is going to delete any rows in the source that aren't in the target. All right, when there's a match, in other words, the product ID and matches, but this condition is not met, then we're going to update the data with the order quantity and the order date. And then, when not matched by target, then going to insert the data. So this is the code that's going to execute the first time I run the stored procedure, because right now, inventory orders is an empty table. And then, when not matched by source, I'm going to delete it out of the target. And once again, have an output statement. And then, each time I run the stored procedure, I'm going to return the current result set of inventory orders. All right, so I'll create that procedure. Okay. And now we can test it. So here's the initial run on that empty table. Okay. So we're going to update inventory. As you can see, there were 4 actions taken because there were 4 records found that met that criteria. So those now exist within the table. And you can see here's the select star that was executed within that stored procedure. So this is the total contents of that table. And all we have is inserts. Okay. I'll execute it again, and this time we have updates. Similar kind of situation to the Marty record in the dogs table, where the data exists, so it was matched. So it updated all the values, but the source values were the same as the target values. And so SQL Server considers that to be an update. Okay, so now let's run the code using a July 1st date. Okay, use the 14th before the July 1st. So this is going to extract different rows from that join, the source data, and apply it against the existing data within the table. Okay, so I'll execute that. A lot more rows involved here. So I have a total of 94 between the 2 queries. So you can see there's a whole bunch of inserts. And then 4 delete statements. So this time when I executed this statement, I had 4 rows within the table that don't match this condition. Those don't match in the merge statement. And so I define within merge to delete those rows. So that's why I have the 4 deletes. And then the remaining rows are all inserts. And the result here, if I select this one, is 45 rows altogether. So I now have 45 rows within that table. All right, now I'm going to execute this again. And as you'd expect, I have all updates, except that I have a couple inserts there. Well, that's kind of strange. I shouldn't have any updates. I didn't change the date. It's going to extract the same rows from the source table. I'm the only person using this database, so nobody else is connected and adding new records that date back to 2005. So it looks like we have a bit of a bug. Okay, and scroll down the rest of the way, and there you go. So we have two inserts. Okay, so here's an altered stored procedure. So it turned out that I had a bug. I had this when matched and target order date doesn't match the source order date. Okay, so I didn't need that statement there. I was erroneously deleting records that I shouldn't have deleted. Okay, so I'll execute this statement that changes that stored procedure. I'll start out with a clean slate. So I'll truncate all the rows within inventory orders. I'll run this once. That puts those 4 rows in there originally. And then I'll run this. I get, once again, all the inserts. And I get 4 deletes. Okay, it's the same results as before. Now I'll run it a second time. And I have all updates. Just to make sure. Okay, we solved that problem of the erroneous deletes.